Hi, I'm a student just like you, your peer. I'm here to share with you my learnings, challenges, tips, and tricks as I learned this concept. So here's an intro to chemical bonding from me to you. At the end of this video, my goal is to help you understand chemical bonding and identifying polar and nonpolar bonds. So let's talk bonding. Atoms are the smallest unit of life and are the building blocks that make up everything within and around us. The number of protons and neutrons and electrons in an atom determine the type of element it makes. The valence shell of an electron helps us determine how reactive an atom is. A stable atom is one that has a fully filled valence shell and follows the octet rule, which you should have already learned about in chemistry. To maintain stability, atoms bond with each other, completing their octet rule. Let's talk about how atoms bond together. Chemical bonding helps us understand the force that connects two atoms together and how they interact. There are 4 types of chemical bonds that we need to know about. Covalent bonds is the sharing of electron pairs. Ionic attractions are the attraction of opposite charges. Hydrogen bonds is the electrical attraction between a covalently bonded hydrogen atom and an electronegative atom. Van der Waals is the interaction of nonpolar substances. These are the 4 types of bonds that you're going to need to know throughout biology curriculum and that you'll constantly see, which will help you understand larger macromolecules. Okay, so covalent bonding. When electrons are shared, you want to help fill both atoms' valence shell. Covalent bonds are the strongest type of bonds, and I found it very helpful to know the number of covalent bonds that you can make in carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, as they're the most abundant in the human body. I've listed the number of bonds that you can make, and I highly recommend that you memorize them because it helps when drawing diagrams later on. I also like to remember the acronym as CHOMPS or SCHNOPS, whichever one, it just helps me remember them. So this is the standard rule for electronegativity. Using this rule, we can determine how atoms interact with each other and if they're polar or nonpolar bonds. So in a polar bond, electronegativity charges are different, and there's a partial positive and partial negative charge. The one with the partial negative is the one with higher electronegativity. In a nonpolar bond, equal electronegativity is there, so there's no charge. So now that we've talked the basics of bonding and covalent bonding, let's talk tips and tricks. My checklist for identifying if a covalent bond is polar or nonpolar is this. So look at the atoms that are bonded. Identify the electronegativity charges of both atoms. If the electronegativity is about the same, then the bond is nonpolar. If not, then the bond is polar. Some things to remember is that almost always, if the bond is between a carbon and hydrogen, it is nonpolar, as they have a pretty similar electronegativity. The more electronegative an atom is, then it's going to be a partial negative charge. If something is less electronegative, it's going to be a partial positive charge. Another tip is to just draw it out if you're ever uncertain. Looking at it always helps, and visualizing is a great tool to use. Okay, so that's a lot of information, and you might be wondering, how do we apply this? So let's walk through a problem and then do a few practice problems. Okay, so let's look at water, which is a popular molecule, which you'll see a lot in biology, so it's great to practice with. So water is also known as H2O, so this is 1 oxygen and 2 hydrogens. Let's just label that as well. So this is hydrogen and this is oxygen. And we know that oxygen has 6 valence electrons based on the octet rule, and hydrogens has 1 each. So if they share, they can total a total of 8, which is what creates a stable electron, which is what we want. So we know that they're bonding properly, which is great. And so you use those rules to kind of draw it out and make sure everything looks good. So everything looks good now. Now you want to look at the electronegativity. So this you can just look online, or it'll be given to you if you're doing it on a test. But hydrogen has an electronegativity of 2.0. So both of these are 2.0. And oxygen has an electronegativity of 3.5. So clearly oxygen has a higher electronegativity, and we said that if it has a higher electronegativity, it's partially negative in charge. So a reminder that covalent bonds are never have a full charge because they're sharing. So oxygen has the partial negative, meaning hydrogens will have the partial positive. And then now we're going to draw the direction towards which the bond is more attracted to, which is oxygen, because it has a higher electronegativity. So this is basically what you need to do for all of these diagrams, and it's your turn now to practice. Okay, so practice time. So identify if these bonds are polar or nonpolar. You have ammonia, which is NH3, C2H4, CH4, and SO2. So draw them out, label the charges, and figure out if they're polar or nonpolar. I hope this video was helpful. In the next video, we're going to talk about the other types of chemical bonding, such as ionic bonding, van der Waals, and hydrogen bonding. So hope to see you next time. Thank you for watching.